Hey everyone, we are starting a new unit today. This next unit is going to be all about circles. Now I know we've done a little bit with circles already. We've looked at area and circumference, and we've also looked at arc length and area of a sector. This unit is going to dive a little bit more into arcs and angles and other fun things that we haven't learned about yet. So on your note sheet, we're going to be doing a lot of definitions. Some of these you'll then transfer into your toolkit, and you'll probably want the examples as well. So here we go. We're talking about circles. Well, what is a circle? A circle is going to be the set of all points that are the same distance from a center point. So a circle is not a polygon, right? A polygon is made up of straight sides that are all connected. A circle has no sides. It's just an infinite number of points that are all equidistant from some center point. So for your picture, besides the fact that we need a center, that would be it, okay? Now we're gonna be using this picture up here for all of our examples. If I wanna name a circle, just like we name triangles, triangle ABC, or quadrilateral ABCD, to name a circle, you're gonna use the center point, right? Because every circle has a center. You're gonna use whatever letter it is, and in front of it, you're going to put a little tiny circle with a dot. Oops. So our circle up here is going to be named Circle F. Circle F. There we go. All right, so it's got the little dot in the center. The dot is to help you realize that it's not an O or a 0. Now, what is a radius? We all know we can identify a radius, but can we actually define what it is? A radius is going to be a line segment. It has endpoints that are on the center of the circle and also on the circle itself. So if I have my picture, that could be an example of a radius, right? It goes from the center to a point on the circle. Now, there are multiple radii, which is the plural of radius. There are multiple radii in this circle. It doesn't matter the order you name it. So you could say, FC or CF. You could say DF, FD. You get the idea. So we're just going to name one of them. So let's just pick one and let's call it FC. And it's a segment, so I put the little segment symbol above it. Now, chord. This might be a new term for you. A chord, is going to be also a line segment, but this one has endpoints that are on the circle. So the radius only goes from the center to the circle. The chord is going to go from one side to the other. Okay. Now, there are 2 chords in this circle up here. We're going to pick AE and name that one. Obviously, I hope that you're pausing this so you can copy things down on your notes and go from there. I need to pause because the baby's crying. Hang on. All right, I got a little buddy with me. We'll see how long this lasts. Another thing to note, we need to make sure we're using all capital letters when we're naming our stuff, okay? Now, our next one is a diameter. A diameter is also a chord, but it's a special chord because it goes through the center of the circle. So if you have your center, your diameter goes through that. Okay, my center's a little off, but you know what I mean. Our diameter here is BD or DB. Either way is fine. Okay. Now let's talk about arcs. In a previous unit, we learned how to find arc length. And we learned that that was a portion of the circumference. Now, a minor arc and a major arc and a semicircle are all related. So a minor arc is going to be an arc that measures less than 180 degrees. So it's less than a half of the circle. So it would just go from one point to another. And I just picked an arbitrary length. As long as it's less than half of the circle. So there are a lot of minor arcs in the circle above. For instance, BC is a minor arc. Now the notation above it is a little different. We put a curve to show that it's an arc. Okay? Now, you typically only need to use 2 letters when you're naming a minor arc, just because it's less than half the circle. And you go the direct route from B to C. I wouldn't go B all the way around. Thanks, buddy. I wouldn't want to go from B all the way around the opposite way to C. You go the shortest route. Now, the major arc is going to be an arc that measures more than 180 degrees. So that's more than half of the circle. He just woke up from a nap. So it would take up more than half of the circle. So right here is about half, so it keeps going. Okay, so something like that. Now, in order to name a major arc, you're going to need to use 3 letters. Because say I wanted the bigger one for BC, right? Instead of just from B to C, say I wanted to go all the way around the other way. If you only use 2 letters, you would go the shortest route. So you need to pick a different letter in between your 2 endpoints. So if I wanted to go from B, A, and then to C. Now remember, we're only going around the exterior. A circle is only that exterior part, is really nothing on the interior. So for example, an arc up here, I could have arc B, A, C. Now you have to use 3 letters to name a major arc, 2 letters to name a minor arc. Now for a semicircle, that's going to be an arc that measures exactly 180 degrees, right? So it's exactly half of the circle. This is one easy one to point out because wherever your diameter is, say I have a diameter that's going through the circle there, my endpoints of my arc are on the endpoints of the diameter. So if you can find the diameter, you can find the semicircle. Now, again, because it's exactly half the circle, you could just use 2 letters to name it, or you could use 3. So for instance, I could name this arc BD, or if you wanted to call it like BCD. So you could do 2 or 3 letters here. Now remember, we're only going around the circle for arcs, not through it. It's not an angle, it's an arc. Now the next 2 we're going to learn about are in fact angles, so we name them a little differently. We've got a central angle. So, careful buddy. A central angle is going to be an angle that has its vertex on the center of the circle, and the sides of this angle are radii, right? So 2 radiuses. So if I have my center here, I know, right? We are going to have this guy and that guy. So that would be a central angle. We already know how to name angles, right? We use the angle symbol, and you're going to draw on my paper. So the vertex has to be the center, and you do need to use all 3 letters, because if you just say angle F, there's way too many angles that all have F as the vertex. So let's look up here, and let's say, for example, we want to name this angle right here. Okay, I will call that angle DFC. So angle DFC. Got my helper here with me today. Okay, angle DFC. And you could also call it angle CFD, and that would be fine too. Now, the last angle that we're going to learn about is called an inscribed angle. An inscribed angle is going to be an angle with its vertex on the circle itself, and the sides are going to be chords. Okay, sorry guys. So it's going to look something like that. Okay, now in our picture above, we don't have an example like that because there aren't 2 chords that come together at a point on the circle. So let's just give these names A, B, C, and this could be angle A, B, C. Okay? Right. Okay, my little buddy went to go get a snack, so we got some time. Down below, there's an example, and I want you to literally pause this video right now and see if you can answer A through H right now, naming all the stuff that you can see, and then we can go through it together. So literally press pause, and then we'll go through it together. Okay, so naming the circle, always name it by the center point. So this would be circle E. Okay, all the radii you see, I see 1, 2, 3, 4 segments coming off of that center point E. So I have EB, I have EC. Remember to put the segment on top in capital letters. I have ED, and I also have EA. All the chords you see. I see 1, 2, 3, 4 chords. Because remember, a chord just has endpoints on the circle. So I see AB. I have AD. I have BD. And I have AC. All the diameters I see. Now, which chords were specifically diameters? I believe BD and AC appear to be the diameters. That's an and symbol. 2 central angles. There are lots of different angles you could have named. I see 1, 2, 3, 4, 5, 6. There's a bunch. I could name angle BEC. That's a central angle. I also have angle CED. So there are lots of other ones you could have named as well. You could have said DEA. You could have said AEB. Yeah, lots of options. 2 minor arcs. Again, lots of options. How about I go with an obvious one? I've got CD right here. Remember to put the arc symbol above it. I could also have DA is less than half the circle. Okay, so those are 2 options. Major arcs, again, lots of options. Now it's got to go more than half the circle. So maybe if I want to go, I don't know, D to B is only half the circle. So if I go to D to A, but remember I have to use 3 letters. So I could say DCA. That would work. How about if I go from C to D to B? C to D to B. All right. 2 semicircles. You could say AC. Remember, you can just use 2 letters, or if you want to use all 3, you could say BCD. All right, nice job. Let's look at a little bit more with diameters and radii. Now, something to add up here. A diameter, as far as its length is concerned, is 2 times the radii, or the radius. And then the radius is going to be half of the diameter as far as their lengths are concerned. So if we're looking at the next page, we have this example right here. And it's telling us that both ST and QM are my diameters, okay? So if ST is 18, so if that's a diameter, then RS, which is a radius, well, it's going to be half of it. What's half of 18? That's going to be 9, okay? Now, RM, that's a radius. If that's 24, then QM, which is a diameter, well, was 24 times 2, 48. Okay? If RN, which is another radius, is 2, then RP, well, that's another radius, that's also going to be 2. All right? See if you can do the challenge problem. It's giving you different diameters and you want to figure out the lengths. I'm just going to write the answers. So actually pause, see if you can try it, and then I'll show you the answers. And if you have questions about how to do it, let me know. This is kind of a challenge problem. So our answer for EZ is 27. And then our answer for XF is 11. Okay. Now, what I want you to do now, I'm going to stop this video here, and then you're going to watch the next video on the angles. But I want you to go into your toolkit, and you're going to fill out the definitions that we've done so far today. So the definitions that you should have are chord, you should have minor arc, you should have major arc, you should have semicircle, you should have central angle, and you should have inscribed angle. The other one on that page, which is arc measure, I'll show you in the next video. Okay?